Hello guys, good afternoon. Well, I think that I have big challenge today, right? I mean, I'm the last talk, and I need to keep energy really up. We will have a dinner in some minutes, right? So let's make this big effort. And I will try to be as more fun as possible, sharing what has been my experience working data science inside Bayer, and I think that you enjoy. So just to help me understand, and I would like to have the people raising hands, who has been working with plant breeding only? I would expect more people, that's fine. So do we have any computer scientists in here? Nice, we have some. Engineering on outside of agronomy fields? Okay. So I think that this is really a nice way to start a talk about data science. Data science is not something about plant breeding, animal breeding, computer science. It's really something that we need to think as global and more people connecting to have a good and open discussion about how to solve solutions to improve our lives. And my expectation today, especially on Bayer side, is to help the team see what we inside of the company are doing with data science. We have been doing a lot of things with data science. This is not something new to us. We're just using this term, new data science term, to talk about the innovations and the science that we have been using. So, and it's funny because less than 3 years ago, I was in the same place as you are right now. I was doing my research on my PhD. I didn't have any clue what was the work and the projects the companies, industries are doing. And after joined the company, Legacy Monsanto, now we are Bayer, I am seeing a lot of new opportunities to use data science in different fields. Not only plant breeding, I will talk a little more what are the other options that we have been doing in the company, and I hope you see some interesting opportunities to apply data science to solve real and scale big data real life problems. In the last few years, we as Bayer have been changing a lot the way that we do business. So I will bring some examples to you guys, probably more connected with technology, but this is how we are thinking in Bayer right now. We are trying to transforming how we do breeding. Up to today, we still have been using some traditional strategies, but this is changing very fast. In a few years, most part of all of our strategies will be really data science driven. So I hope to be able to share this with you. And the third and most interesting topic is what is the kind of breeder that we are thinking to have in the near future. The traditional breeder is going to change very hard. So I want to share some of the skills, some of the behaviors, some of the abilities that we as Bayer think on this kind of professional joining us, helping us to solve a lot of challenges that we have on agriculture side. One more thing, please interrupt me anytime if you have questions. This is any space to have an open discussion, so I would like to have you very comfortable in this journey, okay? This slide is one of the slides that I most like, because it shows how big are our opportunities when working in a big company. We do science, we do research, and we do in large scale. This is what we do. Up to now, we are operating in all of the continents. We have several crops, we have several people, we have a large team working with innovation. And I remember when I was doing my interviews for Monsanto in the past, I had the chance to ask some questions for the people who was interviewing me. And the first question that I thought to do was, well, okay, the position seems very cool, but how much interaction I would have with people from different countries, different cultures, different thinking, because this is how we can create even more opportunities, even more strategies. This is how we can create new solutions for the problems that we have in the face. So this slide is really showing how we are operating, and this is a big opportunity for innovation. So this brings a new way to think on breeding. We are up to now thinking on create global germplasm strategies. This means that we want to select products, soybean, corn, canola, for target environments that specific germplasm was not ever tested before. How we do that, we still don't know, but this is something that we want to do. And when we think in us as Bayer, as a global company, we have three main pillars, let's say it that way. So as crop science, it's one of the divisions of the company. We are intended to shape the agriculture. We want to do science. We want to develop products in a way that any other company is doing. This is per se is something very cool. It adds to all of the people working the company a very hard energy because of the challenge. We have resources. We have very good and talented people working to us, and this is something that and this is actually one of our pillars. And the way that we want to do this is really innovating. How we can connect all the ideas, all the design thinking that each one of you have to create a new solution, to create a new strategy, and at the end we want to deliver value for the community, for the farmers, and then help to feed a growing population in the planet. However, we want to do this in a very sustainable way. This is, we want to do new things, new strategies, new ideas, but we need to make sure when developing this, we are making in a very sustainable way. And we now, as a new company, as Bayer, we have the opportunity to be a company focused on seeds and traits, on crop protection, which is really chemicals, and the digital agriculture. We have one, and I like to say that climate is one startup that we have working inside of Bayer, but we also are developing new digital strategies. So let's think that we have been for all day long a lot of different and new modeling strategies, new opportunities, how we can make this be transformed in a product inside of our pipeline. How we can make sure that this new technology that we have been talking for this day is really something that we can use to make good decisions in a more efficient way, in a faster way. Sorry. And when we think on digital solutions, data science solutions, we are thinking on connect all the strategies for different areas of the company. How we can make sure to develop new solutions, new ideas, and this is strictly connected to what the farmers need, to what the farmers expect to see. This is tailored solutions. This is what we have been calling of tailored solution, which is a combined strategy considering since the development of new genetic inside breeding, but also connecting this to the commercial side, to the production side, and at the end to the farmer. And this slide is very cool because and actually I discovered this slide last week. Rafael told me about this, and then we thought at the same time, wow, this is something that we need to show the guys in the Congress. In the past, we have been producing 10 bushels of yield using a large amount of field. And what we have been seeing over the years, especially due to breeding effort, the genetic gain, is that we have been reducing the size of the field, but producing the same amount of yield. This is really impressive, right? And however, we are up to here. We know that up to now we need to discover and to develop new strategies. So how we can do that? This is what we have been discussing. We have, well, just a guess, but we may have more than 300 data scientists and breeders working in the company globally. Right now, it's an amazing and diverse group of technical people. All of them have a lot of new ideas, good ideas, and how we need and how we can use all of this information that we are generating day by day to really help the farmer to produce more using less resources. This slide is showing how breeding is impacting lives, not only on plant side, but this is something that is impacting lives on the planet, in the whole planet. And using this is the last slide as reference, we have been thinking on design new strategies. If we think, and I want to use some of the presenters' sentence, it's really tough to get big data, right? Well, fortunately, inside of the company, we do have big data, and just to give an insight, we have been generating more than 20 million of data points every year for just one region, just for Latin America. So what we can do and how we should use this information to develop new models, to get new ideas, to get new information, to support a decision in a different way. We want to make sure that the team is really comfortable to bring in new ideas, to make sure that they feel part of the decisions, because this is how we are going to change the traditional way of making breeding. We want to have the team much more focused on collaboration, working together globally, instead of kind of a one soldier task, because working together we can have much more higher impact in the society. And if we think that up to now we have been using automated decisions in every step of our pipeline, development pipeline, if we think that we are already using GWS for several years up to now, up to today, we have been doing data science already. What we can do really to accelerate how to make decisions in a faster way. This is just to highlight, this is just an example of one seed of corn. This is what we send to lab, and just a small piece of this corn is removed for genotyping. And we are doing that for every line in the development pipeline. This is huge. Imagine the amount of information that we are generating with this. So again, we need to find new ways on how to make breeding using the same resource that we have. Thinking on the field side, up to now, we have been talking only about breeding side. We have been talking about breeding. We need also to talk about field testing, right? We need to plant, we need to harvest, we need to evaluate the quality of the data. This is breeding as well. Are we really putting the efforts, the attention that we need on this side? Maybe we still have some opportunities here. So we have been thinking differently how to select the locations to make the screening. So if we are planning to select differently the fields, what are the options we have? This is breeding. This is going to impact directly the selection of our products, of our breeding pipeline. Some 3 years ago, I was in the grad school, and this is not something that I used to learn. So are we really thinking on new in different ways on how to make breeding? Maybe this is something that the teams, the universities, the research groups globally can start to think and design new ideas, new strategies for screening the materials in the field. And we have been using a lot of new strategies for field evaluation. Most of them are already data-driven, data science-driven, using machine learning methods. I'm not sure if you guys are familiar with operations research modeling. I don't think that breeding, animal and plant breeding, are using enough, but I would invite you guys to take some time to check what is operation research, because this is something that the companies are using. It's very popular, it's very familiar with production engineering, but we have not been using at all inside breeding. And artificial intelligence, I will have some slides moving forward, but really the plan for the next few years in the company is to develop, to implement largely artificial intelligence solutions in the pipeline. What this means? This means that we are going to design we are designing systems to make decisions with the breeders, supporting the decisions, but this is per se, this is something that is impacting how the breeding team is going to make breeding. So we don't want to have the breeders going to the field, evaluating plant by plant in our scale. This takes time, this takes a lot of money. How we can make sure to have a new breeding, a new way to make breeding, and even though without any impact on how we are going to select our plants and develop the products. This is another thing that we have in the company. When we think on breeding, we have the breeding side, the breeders developing germplasm. We have the fielding test, which is the team responsible to select and plant and harvest the materials. But to make the planting, we need to have more people working on the logistics side. My intention today is not only to talk about breeding. When we think in breeding scale, we are talking about something much bigger. We have logistics impacting our efficiency as operation metric. So what are the data science strategies that we need to learn? What are the data science strategies that we need to know to support, to design new solutions, to understand how to logistically develop new solutions. This is a picture from one of our logistics center. It's the seed packaging, which is the place where we prepare the seeds. We put all of them in cassettes and then send to the fields to be planted. This is huge. I'm not sure if you have any insight on this, but this is for sure something, this is an area that the plant breeders should be looking at. I don't know if you guys have been discussing, again, this has been using a lot of operation research. So we have several ideas, we have several models, we have several options to solve and to work on this space, but it is not so easy to find the right people to work on here. And you guys as graduate students, undergraduate students, should put a lot of some effort to get more familiar with these ideas, with these methods, because it's really something that the companies will start to look for. Bayer has been looking and doing some of this work, but it's really difficult, it's a really difficult task to find the right people, the right candidates to work with this space. So when we think on logistics, we are thinking something very big, right? So how we can make sure to select the right plant in the right place to optimize and maximize our efficiency, our process. This is a field that breeding is also responsible in the company, and actually it's a sub-team of breeding. And this slide is very nice because it shows at very high level how is organized our pipeline globally, okay? So we have a part of the pipeline really focused on the field side. We have part of the pipeline focused on the lab side. And when I say lab, I'm talking about the breeding selection. I'm talking about GWS selection. I'm talking about our AI selection. We are so big that we have several locations in more than 25 countries. In every step of the pipeline, we have been using analytics to support the decisions of the breeding team. At the end, our metric of success, let's say in the way, would be the level of success on the farmer side, because they will be the person to be growing the food that we are going to have in our table. So as much success they have, we can have less, much more available food in the planet. And this slide is mine from last year. These numbers are mine. We were invited to consolidate the amount of information available we have in 2015. So the colors are difficult to see here, but the light blue is the amount of phenotypic data we have. If you see in 2015, we have a huge, and most part of the data is coming from the fields. This is really the phenotypic data that has been collected in different fields. This is only for Latin America, okay? We have genotypic data available. It's the medium dark blue here. This is the genotypic data that we have been generating for lines and for hybrids. And the dark blue in 2015 was the amount of predictions that we were generating at that time. So when I say predictions, I'm talking about all of the prediction models that we have been talking today, and this has been the base information to support the breeding team decisions at different stages of the pipeline. Last year, so let's say 3 years later, the first picture we have a very different scenario, right? Most part of the information that we have available inside breeding is our predictions. This is sharing a hidden message here. This is saying that, okay, the breeding that we do today is really based on predictions. We are using the predictions to make decisions in different steps, in different stages of our pipeline. This says that we are changing the profile, we are updating the profile of the plant breeder, and this is going to be changing for the next years. Innovation cannot stop. What we, as professionals on the field, need to keep learning, need to keep be doing to be part of this transformation. We are transforming the way that we do breeding. What do I need to learn to be part of this transformation? I think that at the beginning of this year or at the end of last year, I was reading an article on Forbes, and it said that 90% of the whole population on the planet was the people that was following the transformations. And only 5% of these people was really creating the transformation trends. So do we want to be the followers, or do we want to be the people who creates the change? So this is something important that every one of us needs to think. This is something that I think every day when I go to my work. I need to do something different. I want to do something different because this is what we need to do to keep developing, to keep changing, to keep innovating in science. We are scientists, right? So what do we need to keep doing? What do I need to start to do to make sure that I'm the right path of science? This is innovation. We have been doing a lot of research inside Bayer, and before joining the company, actually, I didn't have any clue on how much science we do inside of the companies. And maybe this is a gap between a gap in the communication between universities and companies. I have been seeing that in the past few years we are working to get more connected, and this is something very cool. But we need to accelerate this connection, this exchange, and make sure that we are developing science for a better purpose. And every time that we start to create something, especially when we are in the grad school, my focus at that time was really finish my PhD project, deliver submit my paper, and then get approved and publish a paper. This was my goal, and that's fine. It's the moment of the life that you guys are right now. I was less than 3 years ago, but as soon as we finish a PhD or master in the grad school, we start to think on how I should be part of the universities as professor, company as employees, and then we start to think different how we need to do our work when creating a model, for example, which is just a small piece of the science field. It's my expertise, but it's just a small part of the data science field working on new plant breeding way of develop products. So how am I supporting, how am I thinking on new solutions, and how am I connecting this with a need on the planet? And I think that most of you, I hope, know who was the painter of this painting, right? And it's very straightforward to say, okay, Vinicius, this is Leonardo da Vinci. We have just one person responsible for that painting. But when we think in a large scale, breeding corporation, let's say in that way, and then we are developing hybrids, we are developing soybean products, we are not a soldier responsible to do all of this alone. We have several people working to have that goal. We have people in the region, we have people outside of the region, we have people in different teams. This is a very complex scenario, but this is very cool because it brings us a lot of the personal development. I can say for sure that I learned, and I personally have changed a lot as professional in person. And this is what we are doing more and more inside Bayer, inside a breeding program, especially on a large-scale breeding program. What I can do to be part of this team? Our breeding strategies are changing. The profile of our breeders are changing. My profile is changing every day. Every day I need to learn my work in a different way. So, and this is what you guys have been doing the same in grad school. Every time you have a new paper being released, are we really tracking all of these innovations in the science? So this is something, that's a message that I want to share, because when working in innovation field, we need to be fast. We need to be agile. So let's think that every day matters when we are developing and thinking on new ideas. And I like this company, and I'm sure that most of you does the same. And probably most of you already bought any product from Amazon. In the past, this was known as a bookstore. This is not true anymore. And the reason I want to share this image is because this is a technology company nowadays. But this is not the true if we back 5, maybe 7 years ago. Breeding is becoming a technological company. The traditional way to make breeding is changing fast. So what we have been doing breeding since ever is plant the material, evaluate this material, and make the selection, right? This is what we have been doing for centuries. But is this what we need to keep doing for the future? Is this the way that we are going to solve the big issues, the big challenges? I don't think so. So what we can do as tech company working with breeding, which is a totally different scenario from what we have used to have in the past. We are tech company working with breeding. What we can do to make sure this changes fast. So, and this is a very nice way to show how technology, how data science is changing our lives. Back in 2006, we had Walmart and several other big companies. This is the value of each one of these companies in the market. And 13 years later, we see that the Amazon, which is a very small company in 2006, became very big. This is a huge company now. I may be wrong, but I think that it's the third biggest company in the world. What this company did to change so fast? The company implemented several data science strategies, and when I say data science, please don't understand as only model stuff. Model is very important. Yes, it is. This is, it generates the information how we are going to make the decision we need to do. However, we need to automate the process. We need automated workflows to make bigger and faster, especially in scale decisions. Breeding, again, guys, breeding is changing, and it's changing fast. And I'm very glad to see that all the topics that we discussed today are much more connected with the data science and the breeding of the future than the lectures that I saw last year in some conferences. I mean, the organization is was very happy with the selections of the topics, and I hope to keep seeing this update on topics faster and faster from now on. I'm not sure if you all know this, this algorithm, A9 algorithm. This is the algorithm that is impacting, is controlling, let's say in a way, what products you are more likely to buy when visiting Amazon. A9 is the algorithm that suggests you the product, is the combination of products, if you are going to have discounts or not. Why cannot do that? Why can't we use this idea on breeding? Why not use several of these tech companies' ideas in our breeding? We should do that. We must do that. As company, we have been doing several. We are creating and developing several of these products to solve our needs. And the professional of the future needs to be more engaged, need to be more familiar with these ideas, because this is more and more be the way how the breeders are going to breed in the future. Google, and Rodrigo already shown one of the products of Google, the TensorFlow package, which is very cool. I invite you guys to visit and test this package. It's an open source, it's a free package, and it is a very robust package for machine learning, deep learning options. So we need to keep tracking the trends, we need to keep tracking all the innovations we have in the market. Are we doing this as students? Maybe some of you are trying to keep more connected on what we need to do, but you need to do more. Things are changing fast. Google is a technological company developing very great solutions. You all have been using Google for searching. This is just one of the products. Google has been working in different areas. Why they can do this and we can't do breeding in a different way? I'm an animal breeding on formation from my grad school, but what motivates me the most is not see a cattle growth, you know. It's really how I can do different, what I need to do to understand the new opportunities when selecting, designing, or even thinking different to produce more with less. This is what we need as plant breeders, as animal breeders, as computer engineering, computational scientists, to keep changing, to keep driving the change. And as soon as you guys finish the PhD, start to work in universities or companies, you will see that we will not have enough time to do what I want to do. It's impossible. We have 8 hours of work. We still want to make some exercise. We want to have some free time with our family. How we can do that? It's difficult, right? During the working time, we still need to develop and deliver several things. Automation is part of this discussion. What I can automate, What kind of decision I can automate? Can I automate to make my life easier, to have myself more focused on strategic decisions? What kind of topic should I cover to be more, to have higher success in my career? What do I need to learn today because I may want to use next week? Our lives, we have been getting every day, several papers are released in different scientific journals, right? So how can I make sure that I'm tracking the most interesting and impactful research to be applied in my innovation projects? This is all the questions that we need to do as professionals. As more efficient you are to make these decisions, you may have better and higher impact in your daily lives. And in the same context, we have been generating many data every time, everywhere. We are connected online at every second. I can say for sure that the companies are generating several billion of data points. This is only data. That's all. Data. We have good data, we have bad data, but it's all about data. But then we need to start to think how to make sure that we can extract some information from these data to help us to make decisions. Okay, I have been collecting billion of information, billion of data. This needs to be translated in information somehow. How we can do that? All the techniques that you have been learning in the grad school are useful, but again, 2 years from now, the techniques that you guys learn maybe will be something old, and you need to keep learning and learning new proposals, new ideas, new tools. As soon as we start to get more familiar with the data, with the information, we understand how we can somehow extract some knowledge from that information. This is where we start to think on how to create new solutions in our pipelines. And then, finally, the insights, right? How we can really use this information, this data, this knowledge to support decisions. We need, at the end, this is what it matters. We need to use the information, the data, and the knowledge that we have to make decisions faster, right? So, and this is showing a linear process, but actually this is not so linear. Maybe at the beginning of a new trait that we are collecting, it's a linear process, but as soon as we start to think in a trait that is already collected in the pipeline, this is a kind of mixture process. And this eventually and somehow we start to be connected with different traits in the pipeline we have. And I have been seeing a lot of discussions around analytics. And I have been studying for the past 6 years, a master and PhD, studying models, how I can use which is the best model to solve this kind of issue. But when I started to work in the company, I saw that models are one of the pieces of the workflow, but it's not the most important piece. What and how I can make sure that I'm understanding how to develop workflows, how to develop strategic thinking. Even on my paper, my draft that you guys are writing during the PhD, during the master, because you need to think, you start to think more, you start to think differently in the grad school, because this would be much easier when developing something in professional lives. And what I have been seeing is that models has been ranked as the most popular and talked topic. And all of these things are very important when we think on scalability. And this is not have been talked as much as it should. So what do I need to learn to be more familiar with different topics as infrastructure and data center, for example, workflow solutions? I think that someone talked about AWS. We have several solutions in AWS, Amazon. We have some solutions in Google. So this is the kind of curiosity that each one of us needs to have to get as more familiar as possible with this kind of data science type of skills for the future. And this is very cool, right? Because probably you may know what are each one of these symbols. I am sure that you guys know R, Python, perhaps Jupyter, but these are the softwares. We have also our studio here, but these are the softwares that we use to create models. But these are not the softwares to create a solution. This is one part of the solutions. I will not say what are the other signs. Feel free to take pictures. My recommendation is try to get more understanding what is each one of the softwares. Maybe you will not be able to use today, but maybe in the future. But I'm sure that maybe in 2 years from now, these are not going to be the softwares that you will need to solve your real life challenges. But this is something that the industry is really using to support decisions, to support processes, to support automation. We are almost finishing, okay? So I have some messages, very important here. So creativity is very important. In a few weeks, or maybe years, months, most of you will be a doctor, will have a PhD, will have a master, and this kind of makes you a science and a reference in the field. My recommendation is be creative, be as more creative as possible as you can. Innovation is about creativity. It doesn't mean that you need to work alone. Actually, I'm the opposite way. I do like to work with big groups, in diverse groups. Creativity is the engine of all the innovation we do inside of the companies, inside of the universities, on the science field. And it's never too late to learn new things. As scientists, as researchers, I keep getting several of information every day. How do we need to make sure to get as more familiar as possible? Of course, you need to be aligned with what you need to deliver, to deploy, on your work. But it's never too late to learn new things, new ways to make the same work. How can I do what I do in a different way? We have several researchers say that if we start to do the same work in a different way, this can trigger a lot of brain zones for creativity and for learning fast. So as more connected as you are with different ways to make the work better for you as professional and as person. Some of 3 words very important in a modern world. This is not only for companies, okay? Universities, the teachers and the professors of the future will need to be as more agile as they can. They need to learn new things faster, and they will need to create more collaboration strategies to be more effective and deliver faster solutions for the society. And inside Bayer, we do all of this in a very sustainable way. One of the main pillars to us is to keep innovating to deliver solutions for the farmers, but we need to do this in a very sustainable way. This is a very common message. You may know it's Norman Borlaug, right? It's very popular in plant breeding, but innovation cannot wait, especially on agriculture. The population in the planet, it's about 8 billion people in the world, and we are getting more and more people every day. We need to feed all of these people. How we can do this? How we, as scientists and researchers, need to do our work to make sure that we are making our part to help this happen. This is everything that I have. I would like to thank you, the organization, for the chance to be here and talk a little bit about how we are thinking on data science inside Bayer. It was a great opportunity. Thanks.
So we are open for questions. Any question? So I have a question. Are you waiting? You drink your water. As we know, most of the researchers in plant breeding usually use the genotypic and phenotypic data. So I would like to know your opinion about the other types of big data, like transcriptomics, proteomics, metabolomics. Do you think it will be possible to implement them together in plant breeding programs?
Mm-hmm. That's a good question. So when we think on company effort while making breeding, yes, we want to use as more information as we can, but the first thing is really define the value to add these new kind of traits in our pipelines. So usually what we do in the industry is really we do some small experiments to understand how we can make use of this type of information. If we see value and we see some improvement on the production, on the yield traits especially, yes, we start to do.
Any other question? So thank you very much for your great talk and answer.